This Jeremiah, la 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 la. Beamer, 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 beamer body operates. Don't say what's on your mind, get loose. Even though I'm the one, I seem like my girls in twos. They get goose.
We're going to present to you 10 steps you need to know if you want to pass. Okay, so our problem says x squared is equal to x minus 2 over x squared minus 1. So, let's begin. Okay, so step 1, determine an intersection. So, we have the basic principal function. So now we know that x squared minus 1 cannot be equal to 0. So x squared cannot be equal to minus 1 because we have this minus 1 to the other side. So it's plus 1. Now x cannot be equal to the square root of plus and minus 1. So, the domain is all real numbers except minus 1 and 1. Now, this is step number 2, and it's about finding the x and the y intercept. Pretty simple. Y is equal to 0 for x intercept, so you're going to get a point of 2, 0. And then for the y intercept is x equal to 0, and then you're going to get a point on 0, 2. And these two are your points for x and y intercept. Okay, so now step 3, the symmetry. So we substitute in for the x, and we got that it's odd. And now the minus f, and we substitute in too, and it's not even, so it's no symmetry. Now, let's see, this is going to be step 4, and it's very simple. It's finding the vertical asymptote, which is very simple. You're going to prove this with the limit, and the minus 1 is already previously get, and then you just like substitute this minus 1 on the original function, gives you minus infinity right here, and then again, but with the right side, and then it's infinity, and again, but with our n sign up front, and it's infinity, and once more, and it's going to give you finally minus infinity with all the steps. Okay, so step 5, the horizontal asymptote. So now we substituting for the x's in the value infinity to the negative, and it gave us 0, and then infinity to the positive, and it gave us 0 too. So since they're equal, the horizontal asymptote in y is equal to 0.
Okay, step 6, further derivative. We have a quotient rule, so we apply our quotient with the result of x squared minus 1 minus 2x squared plus 4x over x squared minus 1 to the second power. We factorize, we add another, and we have our final result, that is negative x squared plus 4x minus 1 over x to the 2 minus 1, all that to the 2. So, our next step number 7, first derivative test. We have our derivative, so we need to substitute these values in our general formula. So, we obtain that our first x is 0.26, like is shown here, and 3.73 in here. We didn't show the steps because we don't have enough time, so that's the result. So we choose a value less than 0.26, so we have 0, and greater than 0.26, 1, and less than 3.73, 1, and higher than 3.73. With these values, we substituted in our original formula to obtain our signs, and with this we obtain the minimum and maximum. So in 0 is a minimum because it's negative, in 1 is positive, so it's a maximum, and in 4 is a negative, which is a minimum.
Okay, so now we're going to the step 8, which is the second derivative. So now we derivate the first derivative. So it gave us this big result right here. And then for x1, which is the value we're going to use for the IT test, we find it out from this part of the derivative. And then the x2, which is 5.52, which we're going to use also on the IT test, we find it out from this part of the equation, derivative. Now, this is step number 9, which is the ID test. It's almost the end, so don't worry. We have x, the second derivative of x, and f of x. We've been told before that we needed some values that we got from the second derivative, which was what? Minus 1, 1, and 5.52. With that, and substituting on the second derivative, you get something, and you need to substitute the minus 2, 0, 2, and 6, which are values that approximate to these numbers. You're going to get on the second derivative a minus, and then with a negative concavity, and then for the 0, you get a positive with a positive concavity, and then a negative for 2 with a negative concavity, and a 6, a positive with a positive concavity. And just before we finish, with these values and all of the information that we got before, we can do the graph, which is going to be the last step, step number 10. Thanks.